We have a uniform piece of card in the shape of a letter L is suspended freely from a horizontal pin. A plumb line is also suspended from the pin, and the whole thing is in equilibrium. We're trying to work out the position of the center of mass of the piece of card. So, the plumb line is basically a mass which is hanging off the end of a string, and when you do this, when the plumb line is just resting in equilibrium, this string will be completely vertical. When you have the piece of card suspended freely at point A, if it's in equilibrium, the center of gravity of the card will be directly beneath point A. If the center of gravity weren't directly beneath point A, the card will then rotate about point A until that is the case, and only then it will be in equilibrium. So if that doesn't make sense, I can give you an example. Let's say we were to have a picture hanging off a wall, and let's say, for simplicity, there is no friction in this wall. We have a string, and let's say the picture is hung from a nail over here. So the weight force is here, and as you can see, that weight force is not directly beneath the pin. There is some kind of perpendicular distance from the line of action of the weight force to the pivot, and therefore there will be a moment. The moment would be an anti-clockwise moment. That will cause this whole picture to rotate anti-clockwise until eventually the center of gravity is directly beneath the nail. So in the scenario that we have over here, it's the same kind of thing. The center of gravity of this shape must be directly below point A. We want to work out the center of mass. The center of mass is the average position of the mass in an object. The center of gravity is the point from which the weight force acts. Center of mass and center of gravity are the same thing in a uniform field. They have different definitions, but their point will be in the same place. So we're basically trying to work out what is the average position of mass for this card. The average position of mass would be at the same point where the weight force acts. It has to be directly beneath point A, so therefore we have three options. It could either be A, C, or D. It can't be A. The center of mass, the average position of the mass, can't be at A, that's all the way at the top. Nor can it be at D. It can't be at D because if I were to draw a horizontal line, what we can see is that beneath point D we have this much card, and the area of the card is proportional to the mass of how much card we have, as it's a uniform piece of card. And above point D we have this much card. So there's a lot more card above D than there is below. And for that reason, D would not be the center of mass of the card. It would in fact be C. So let's do the same kind of thing where we draw a horizontal line at point C, and then we can shade what's above. This is the amount of card that we have above. The amount of card that we have below, they are pretty much the same. So along that line that contains point C, we have as much card above as we do below. Point C is also directly beneath the pivot, and therefore it must be the center of mass.